So that's what you need to understand. So when you do that, we are able to also talk about how human reason and how computer reason. Okay, in human we tend to overlook ambiguity. You understand? You tend to fill in the spot. Sometimes you reason the way, even if the information is not okay, is not complete. However, for computer, you need to explicitly, you don't imply it. Computer will not think, will not say, oh, you forgot a semicolon or you forgot a statement. Oh, I will help you fill it. No, it does not do that. So every step all the way must be explicitly stated. You have to write, so and computer does not want ambiguity. Okay? Shemilori, always meet yourself. Does not want ambiguity, and these are what we discussed in the last class. All right. So today, the very quick one, we'll be looking at what we call a flow chart and a pseudocode. Pseudo means false. Okay, false code. We'll look at what a flowchart is, and what a pseudocode is. Okay. All right. So let's kick off. So let's look at the introduction. The introduction says once a problem has been clearly defined, which we've done in the previous class, okay, and the algorithm logically developed, you've developed the algorithm. The next step is to represent the solution in a clear and visual manner, okay, in a clear and visual manner. And one of the most widely used tools for this purpose is the flowchart. Sometimes as a developer, you are in an executive meeting, let's say with your boss or with a client, and you want the client to be able to follow through how you will convert the problem into a solution. Okay. And the client needs to understand the logical flow, okay, of how you will be solving this problem. One of the tools you will use is a flow chart. It's a chart that can flow, that shows the flow that a layman can easily understand the process. All right. So we'll be looking at this, and hopefully I can give you an assignment of that the class to draw a flowchart. All right. So um, in essence, what is a flowchart? A flowchart is a graphical representation. A graphical, you can see it, you can visualize it. All right. It's a graphical representation of an algorithm or a process showing the sequence, how it flows. What step do I take after another? Okay. Sequence means you know how the process flows. Which one comes first? Which one, you know, um, is the second, third? How do I deviate if this does not work? Okay. So it shows the sequence of steps using standardized symbols connected by arrow. Okay. So if you have those standardized symbols, you need to show how they connect, how they link up to each other. Okay. So do not forget that it is a visual, it's a graphical representation, okay, of an algorithm or a process, and it follows a sequential manner. So how do we draw our flowchart? How do we represent our flowchart or algorithm? We use standardized symbols, okay, and arrow connecting the chart. We use arrows connecting it, okay. So what are the advantages of flowcharts? It provides a clear visual understanding of the logic, okay. Basically, your programming is when you are writing code, you are converting the logic of the problem, you are converting it into a programming language. Okay. You're writing it in a programming language. So a flow chart is just like this. If you have your algorithm, there are many ways you can represent your algorithm. You can represent your algorithm in a flow chart. You can represent your algorithm in a pseudocode. You can represent your algorithm using an UML. Okay, you can represent your algorithm finally in a programming language. Okay, they are they are all the same logic. Okay, so it provides a visual, again, a visual understanding of logic. It helps to detect errors before you code. It helps you to visualize the entire logical step, logical unit. What do I do first? Okay, so it's just like this. If I want to um, represent the flow of an ATM machine, I can say, what's the first step? I can say if input your PIN. So input, let's just say input PIN. Never mind me on my diagram. Say input your PIN. So what's the next step after input the PIN? Oh, I can say, oh, okay, verify that the PIN is correct. Verify that the PIN is correct. So if I verify if it is true, I can true. If it is true, go to the next step. If it is false, I can print enter your PIN again. Then if I have to enter my PIN again, it means I have to come back to this process. Okay. So if after verification it's okay, then I can ask what transaction do you want to perform? You understand? So these are logical steps. You will see that even if you're not a non-programmer, you looking at this would actually help you see the entire flow. Okay? Because sometimes in the entire software development cycle, we have different um, stakeholders who are non-programmers. Okay, even the client could be a non-programmer. Most of them are non-programmer, and you need to show them or you show your team the logical flow. Okay, so these are visual. You can see how it works. Okay, so it helps you detect error before coding. Sometimes you see, oh, this is not the next step we should do. That step, okay, we need to include this. Okay, so before you start coding, you can visualize and get more input. Okay, um, one thing about programming is once you would understand the algorithm, you understand the process flow. All right, coding is is does not take time. In software development, coding takes, let's say, approximately 30 to 35 or 40 max, 40% of the time. Coding does not. You're just representing your logic in a programming language, in a programming way. But you understanding the process first, the problem statement, okay, the input, the process, the output, you understanding it first, and you testing your code takes more of your time. You testing your code takes more of your time in and if you have a very good understanding of the logical process, okay, you will have little error in coding. Okay, so it improves communication among developers and stakeholders. Remember, in if I have to develop, let's say, an accounting package for a company, remember, I'm not an accountant. Okay, as a programmer, you might have a little knowledge about accounting. All right. So what do? You have to interact with the company, the accounting company. You might have the MD. You might interface with each unit. Okay. And so those units, those stakeholders, those that will use the software, they are not necessarily programmers. So how do you ensure that they are rightly carried along? Okay. So it helps you to improve what communication. All of you are using the same language that is not programming centric. Is not based on a programming language. So you both have the same communication platform. You understand? So it also serves as documentation for future reference. So if you have the the flow chart, have we completed all the stages? Okay, so it's very important. Um, it serves as documentation, simplify debugging, and maintenance. All right. So and one thing about flowchart is it is independent of programming language. It's not tied to a particular programming language. All right. Uh, then after having your flowchart, then you can now say, oh, let me now use a particular programming language that would easily help me to solve this problem at hand. Okay. So it is independent of the programming language. I hope you guys are following. If you are, kindly say
Yes, sir.
yes.
Yes, sir.
Yes, sir.
Yes, sir.
All right, thank you. Thank you so much. All right, so let's move on. That's the advantage. Let's look at the disadvantages of using flowchart. It is difficult to draw flowcharts for large and complex programs. For large and complex programs, when you're writing programs that are just some few lines of code, 10, 20, the steps are just 50. But for complex program like operating system and all that, having having about millions lines of code, like Facebook, having millions lines of code. How do you represent the entire program using flowcharts? Okay, so it's difficult. We're not saying it's impossible. Okay, it's difficult. There's no standard to determine the amount of details. So the amount of details, there's no standard to say, oh, this is how you limit the amount of details. Now, it's difficult to modify a flowchart. Once you've drawn it, you can modify it, but sometimes you need to rework. You need to redo your rework. You rework the entire process. Making a flowchart is also costly. Okay, it's costly. Sometimes they are the software being used are not free. Not everything is free. Okay, they might tell you, oh, for certain features they are free, but for larger for you to have certain features you have to pay. Okay, so if changes are done in software, okay, because in the next class, hopefully the final class, I will tell us some models in software development. We have something like water flow model, agile model, and we'll look at what we call DevOps. Okay, so sometimes you retweak your problem statement or you retweak your changes if there are some things that are not captured. If the client can come tomorrow and tell you, oh, sorry, we forgot to capture this. So what do? You have to rework. The flow chart must then be redrawn. Okay. So these are some of the disadvantage. The disadvantage does not negate the use of flow chart. Okay. So these are some of the disadvantages of using a flow chart. Okay, so let's quickly just look at very simple flowchart symbol. This does not capture the entirety of the symbols because we have a lot of symbols, okay? So these are just basic flowchart symbols and the meaning, okay? So flowcharts use standard symbols and all of them have specific meaning, okay? Number one, you have the terminator. If a process or a logical flow will have to be terminated or to start. Okay, So it's represented by an oval shape. Okay. So indicates the start and end of a flowchart. If you have to start and end a flowchart, you use the terminator. Okay. So example, for you to start or for you to stop. All right. So if you have a process, you want to compute, you want to calculate, okay? You want to process anything. You have some values you want to add, subtract, you want to do some computation, okay? You use a symbol, a rectangle symbol to do that, all right? And so it represents a computation and what? A processing step, all right? Um, Example, you want to calculate sum, you want to assign a value, C equals A plus B, that's computation. So you use a what? You use a rectangle. Input and output, you use a parallelogram, a parallelogram. Okay? So a parallelogram is almost like a rectangle but skewed to the side. Okay, so they're used for data input or output. Okay, you want to read the number, you want to accept inputs from the user, then you use a parallelogram, or you want to display the results. Okay, so this symbol is used. For now, you will see some examples as we go on how to use them. Okay, so never mind, just follow through. Just follow through. So you want to make a decision. Decision, the symbol for decision is diamond, a diamond shape. Okay, want to make a decision. Is A greater than B? Is A less than B? Is A equal to B? And all that. You want to make a decision. So it represents a condition that branches the flow. Branches the flow. What that means is the branches the flow means that if let's say is A is A greater, let's just say we don't write is A, we just say A greater than B. Okay, so let's just say A greater than B. If it is true, let's say you do this step, print A is true. So if we want to print, remember, um, what do we use to print? Let's go back to print. We'll use a parallelogram. Okay, so let me erase. I'm just showing you some of the steps you go through. So to print, you can then say, right? Then you can just use a parallelogram. If A is greater, just say print A. Print, you can print A. Okay, so it means you draw your arrow. That's then you say if it is true, and just write T, true. But if it is false, what do? We can come here and print B is greater. Okay, so the same parallelogram. At the end of the day, if that's all we want to do, it means these two will converge, right? It's just to print A is greater or print B. Okay, if that is what you want to do, then you come and what do? You stop. How do you represent your stop? Okay, with an oval. Okay, that's for you to stop. Okay, so those are just the basic graphical. The more you're used to it, the more you know how to represent this. So the flow showing the direction of flow is an arrow. So you use an arrow, and those arrow must connect. So look at this now. You will see that the arrow did not connect. It's just jumping. It's not connecting to this block. Okay, so that shape, it must connect. So you ensure that it connects. If it doesn't connect, it means there's no flow. Please always allow the arrow to connect, right? So, so if this is true, it means this will be false. Then you could also have another case. If A is equals to B, then you make a decision. Okay. Maybe you print A is equals to B and you stop. Okay. So all of them. So these are ways to just represent. And you have connector used to connect different parts of it. Sometimes when you are drawing your flow chart, let's say I'm drawing my flow chart and I've exhausted maybe this page. I need to go to another page to continue. So all you just do is you just use your connector here. So when you go to another page, you continue and say, oh, from the connector, I'm continuing. All right. So that's the use of it used to connect different parts of a flow chart. Okay. So after drawing all my diagram, because flow chart can be somehow or somehow cumbersome, all right? You have a lot of pages. So how do you connect those pages together? How do I know that, oh, this continues on the next page? All right. So while going online this morning, I saw a site. I would I would still give you all this. I will give you all this. I saw a site, um, visual paradigm. Let's see. Let's see. Go to site. So I made it an hyperlink. So you clicking on it takes you to another page. Okay. Um, so we'll visit the visual paradigm. I've clicked on it. It's loading. Okay. Let me wait. Sometimes you just have to manage mass system. Let's wait. Okay. Okay. So in okay, this I have the site already open there. So this is the visual diagram, visual paradigm site. Visit it. Okay, telling you what is a flow chart. It shows steps in sequential order. You can see. So, and it's used to represent the flow of algorithms, the workflow, the process flow also. So you can see start and stop. You can see start, stop, or end. They have the same shape, okay, the same oval shape. Power on, you want to do a test. These are this for printing, you power on. These are for input scan, input, and you can see this is a summing junction. Okay, a summing junction. You understand all this. These are for decision. Okay, if the battery is low, yes, you off the vacuum. If the battery is not low, then you ask yourself, is the vacuum full? If the vacuum is full, yes, you off the vacuum. And when you off the vacuum, you stop moving. Okay, you stop moving and you indicate an error. You know, this is to show output, input, output. Okay, this parallelogram is to show input and output. Okay, so if you indicate error, then power off. Okay, so you can see sometimes you just see some arrows connecting. You see a summing block and other. So visit this site to look at what it's the symbols. These are symbols. Sometimes you want to print documents or a report. You have things like this for document. Decision is the diamond shape. On page, off page, you want to have a delay, you want to have a flow. Look at examples. Okay, I have this example here. You can see different examples. and all that. So you can just look at this site, and so if you go to the supermarket, you start, you add item to the cart, checkout, shopping cart, set to your payment, so stuff like that. So that's that for us. Let's go back to our slide. I hope you guys understood all I've been saying. Okay, are you following?
Yes, sir.
Yes, sir. Yes,
Yes,
All
sir.
sir.
right.
Yes, sir.
So I never bother too much because all these informations, if you go online, you see a whole lot of um write-ups of flowchart, symbols, and all that. Okay, so if you have a task like you want to determine if a number is even or odd, you start to check if a number is even or odd, you start, you input the number. You can see input. For input, which tool do you use for input? Okay, parallelogram. So you'll see that a parallelogram is used. You want to make decision. Now, the number being input, okay, is can it be divided by 2 and there's no remainder? If yes, it means an even number. If no, it means it's an odd number. Okay, so if you find the modulus of that number, okay, modulus 2 of the number or mod 2 of that number, if it gives you no remainder, then you know that yes, it's an even number. Otherwise, it's an odd number. Then I'm done. Okay, when I'm done, I come to stop. Right? So these are just basic examples. But for now, you know why all these shapes, what this shape does, what they do. Okay? So you could be asked to draw, they can be asked in your exam what this stands for. So it's good for you to know. Okay, you could also have something not complex, like not too complex, which I retrieved from the site. Um, Okay, so let's show the entire step when a patient comes to the hospital till the patient leaves. So when it comes, let's say you start the process, the patient arrives, then you want to make a decision. Is the patient a registered patient or no? If it is not a registered patient, what do? You register the patient. Now, what's the next step? You ask again, have you registered the patient? Yes. If it is now yes, then you check the available nurse. Sometimes after checking the available nurse, if the nurse is available, you you record the health condition. Sometimes when you go to the hospital, the first thing is they take your basic, uh, they conduct some basic tests. They look at your temperature, they check your BP. Those are just basic. Then after the nurse has done that, if the nurse is not available, no. If the nurse is not available, you wait for available nurse. Then, if yes, if a nurse is not available, then the nurse can record your health condition, basic health condition. Um, then after recording your health condition, we want to see if the doctor's available. If no, you wait for available doctor, sit at the lounge. If the doctor is available, you assign the patient to a doctor, need follow up, arrange appointment. All these things now are good. See, for now in modern hospitals, these things have always the record are now electronic record. It is most of the time in general hospitals that you'll be carrying file up, around. In modern hospitals, all you do is they assign you a number. Okay, they know your ID. If the doctor has to prescribe anything for you, he type all this on his laptop, okay, on your record. Then when you go to the pharmacy, pharmacists within the same hospital or the dispensing unit. They just pull up your ID. They know what the doctors are saying. So if you are going to develop a solution for them, sometimes you have to use a flowchart to represent all these steps. So if I'm a stakeholder, okay, I can tell you, oh, you did not capture some certain features, which okay. What if the patient is an emergency? You don't have time to be waiting for nurse. You just have to be taken to the ward directly. So it means you will have to skip certain process. So all those stakeholders will be able to contribute based on this flow chart. Okay. So flow chart is not program dependent, not attributed to a particular programming language. Okay, you can see these are just normal logical flow. And I tell you, um, some of the best programmers are not necessarily from engineering, computer science. Good if they are from there, because sometimes all these things are logical process. Programming is logical. As much as it is science, it's also an art. Okay, these are the work of art. Okay, so you don't necessarily have to be computer science, engineering, but most of people in those specializations, they are very good at what they do. Okay, so this is an example of a flow chart. Let's see. I just wrote few flowchart softwares. We have my rights of software. Even you can do flowchart here in my PowerPoint, Microsoft PowerPoint. Okay, so just look at this. If you go to insert, look at insert, and you go to shapes. I hope you can see my screen.
Yes, sir.
Yes, sir.
So if you go to insert, if you go to shapes, you will see recently used shapes, rectangles, basic shape, base. You will see flowchart. Look at this flowchart. Now, look at this. If I point to any shape, you will see this is telling me is a process. Okay, so process, that is to say you want to assign, you want to do any computation, A equals B. You want to add, you want to divide, and in process. You come here, alternate process, yeah, flowchart decision, yeah, was it saying data? So input, output data, what do we have? Predefined process. This, it's more like multi-document. You can see it's multi-document, terminator to start and stop, preparation, manual input, manual operation, connector. You can see connector if you have multiple flow charts and you need to connect them and all that. Off-page connector. You can see, let me show you this. Punch state. What is this? Summing junction, where you have several processes coming to a point. Okay, so or collate. So they are just symbols, sort and all that. Let's see, store data, delay. You want to have some delays, access, sequential access. All these more like data or where it's being stored, direct storage access, and what to display. Okay, you can see. So I can come here and click, let's say decision now. I draw my shape. Can you see? I can still come down and say, okay, I need an arrow, drop down arrow from there, then I have this um, a rectangle. So before you know it, you're drawing, you're already drawing. Okay, so um, so you can also use something like visual. It helps you to draw. Um, something like Microsoft Visual. Hope I have, yeah, visual, yeah. You have a visual like this. They'll also help you to, okay. So you can have a blank diagram, basic diagram, and do, let's just say this. So that's this our visual looks like. Let it load. So this is your um drawing environment, your canvas. So different shapes, right? So you can have your rectangle, let me drag it, the rectangle, have a parallelogram, just like this. You have the connectors. Let's see, connectors. Sorry, so just pardon me now. Okay, so you can see your connectors and rearrange all this. So you must be conversant with how to use visual before. So the more you use them, so when I click on my connector, you can see you have different shape style. You can increase the line, the thickness of the line, if you want it to be more thicker, you want it to be dashed line, okay, you want to show a bi-directional. So all this can be done there, okay. So you could also search for engineering shapes. There are some engineering more shapes, flowchart. You can see flowchart and draw some networking design, computer memory monitor to load certain things for you. Okay, draw PC. So all this, I don't. My job is not to teach you how to use them. It's just to point you out how to connect them. So if you have coming, so you can come to more shapes. You can search uh, software and database, UML design, entity. There's a lot. There's a lot here. So, guys, just look at all this. Say no. Okay. So let's go back. Let's go back to where we stopped. Okay. So you could have Microsoft Visual. You could use even PowerPoint. You could do C Chat. So I just went online and saw a video on Lucy Chat and see how they can help you connect. Okay, you have your tools available. You can say when you draw them, you know. So if you notice, you just do so it's faster rather than you going. You want to connect this to another rather than you picking up a connector. You just drag and drop and all that. So this just speaks from the site how you can connect them and, and all that. Okay. Um, this, that's some common flowchart software. So we want to go to another concept called pseudocode. Pseudo means for code. You understand? A pseudocode is an informal high-level description of an algorithm. It's just a description, high-level one description of an algorithm written in plain language. sometimes mixed with programming constructs like if, while, for. Okay, so it's an informal. You is more like you writing your programming uh, steps or your logical flow in high level language, more like in your own way. Okay, so what we do is we mix them with programming constructs such as if, while, and follow. So what are the characteristics of a pseudocode? It's not written in any specific programming language. Okay? It focuses on logic, not syntax. It's on the logic. Remember, it's always on the logic we are focusing on, not on the syntax. Okay? Because a particular program can be written, a particular Sudoku can be written in any language. You can decide to write it in C, C++, C Sharp, Java, F, Q Basic, whatsoever, maybe Fortran, any any language or Python, whatsoever. Okay, so it's not focused, it's not written in any specific programming language. It focuses on the logic, what needs to be done, okay? Not on the syntax, how it is written, what you want to do, not how it is being done, okay? I want to add two numbers, not how do you write them, okay? It's easy to read and understand, can be translated easy into actual code, you can see. So when you understand your representation, you maybe you are not even the person that wrote the algorithm or the pseudocode, but once you look at it, you understood what you are required to do. Then you can actually translate all that, even the flowchart, the pseudocode, you can translate them into actual code. Okay, so why use pseudocode? Why do we use them? Pseudocode is used because it helps programmer plan solution. You have to plan. I need to make you understand that software development is capital intensive. Okay. Um, Everyday programmers are okay. Just imagine if you have to employ someone to write a program for you. Every day you have to pay the person, depending on what tax you're giving to the person, maybe in dollars. Okay. So it helps you to plan your solution. Just imagine you're building a company, you're building 100-story building. Oh, then later you now change your mind and say, oh, it should be 150. How do you tweak your architectural design when you've already built, or you want to say, oh, I want extra floor here? It's it's not possible. Although for programming, sometimes we go back, revisit, you know, and we edit our code sometimes. But for each program, going back to re-edit, we have to change the paradigm, and it's costly. Okay, it's costly. Programming also, software development is costly. Okay, don't just look at it as just you just edit, you just change your no, it's costly. So you need to plan for real software development. You need to plan. You have a whole lot of team, let's say like 50, 100 programmers. If you don't plan, it means the software might not even see the light of day. Okay? If you don't plan, you might end up having bogus solution. Because there's something we always call MVP in software development, MVP. MVP stands for minimal viable products. If I tend to develop all the features at a go, all the features to make it robust, then it would take me a whole lot of time before I have a product that I will sell to the market. I'll bring to the market. While if I have another product, if my competitor have a product that has MVP, minimum viable, it can do at least some basic functionalities I need, then that product will be acceptable by the customers. Okay, and they can maintain their software and add more features. So that's why you always have version 1 of software, version 2, version 3. You understand? Look at your Windows. You have Windows XP, Windows 95, 98, Windows XP, Windows 2000, okay, Windows 10, Windows 11. The features they keep improving, but just imagine they they have to wait till they have Windows 11. It means before they get to the market, someone has captured the market share. Okay, someone has taken all the market. I remember one thing about we user, we always remember the first product that comes to the market. Sometimes you ask someone, "Oh, which toothpaste do you use?" They will say Maclean. Which toothpaste? Every toothpaste is Maclean. No, Maclean is just a brand, not or close up. They don't tend to remember others. Okay, so the first person to enter the market with minimal viable product wins. Okay, so you have to plan. You have to plan for your solution before coding. At what point do I stop? At what point do I say, oh, all these features will be added in the next release? Okay, so pseudocode help programmer to plan before the actual code, helps to reduce logical errors, improves communication among developers, independent of programming languages like Flowchart. Virtually, virtually everything in the Flowchart also it's yeah. Okay, yeah. Okay, so let's see. Let's go to the next slide. Okay, although pseudocode has no straight syntax, the following conventions are used. It does not have a syntax where you have to strictly follow. Okay, but we use simple English statements. Simple English statements. Okay, one instruction per line. Simple English. You don't start writing vocabularies and writings, you know, a whole lot of grammar in one statement. No, or have several lines just for one. So just a simple statement. Read or get inputs or input A, B, C. Okay. Um, so write one instruction per line, use capital letter. These are just convention which we adopt. Okay, we adopt. Use capital letters for control keywords like you want to make decision if, you want to make an iteration while, for, use for loops. Those in computer engineering, I taught them um, um, LAX, CP 11115 and 116. So they are used to programming. Okay. So indent block to show structures. To show structure, you need to indent the block. Clearly indicate start and end of the block. So let's see an example like this. I want someone to tell me what this program does. Me looking at the pseudocode, can you tell me what this program does? The first program on my left hand side. Yeah, so I Santoshuku is I know you're good. I won't want you to. I won't want you to answer the question. I want uh, someone else to try. Thank you, Tom Toshuko. Okay. Any other person? I want someone to try. You could actually put it in the
Sir,
comment. Yes. Who is
is
that?
used to Anikwala.
Yes. Okay.
That is used to get the area of a shape, or prints the area of a shape.
Okay. You get the area of the shape and you print it out. Good. That's
Yes, sir.
wonderful. Yeah. So you start. You get the length. You read the length. You read the width. Then you multiply the length and the width, and you assign it to area. Okay, you assign it to area, then you print the area. Good, that's awesome. You can see this is not tied to any programming language. There's no syntax structure. Okay, there's no syntax um, or structure tied to any programming language. All right, so let's look at this second one on my right. All right, can you look at it carefully and tell me what it does? Because it's a force code, it's not really a code, but let's look at it. What does it do? O E Oluwasemilore. Yes,
That to determine whether a number is even on or odd.
Shemilore, this your voice sounds somehow. Okay, so determine if a number is what? Even or odd. Okay, so when you have the modulus of this, then you can. All right, all right. I'll look at my time and I will see, I will show you if I can code it. Okay. Yeah, that's good. That's good. So what do? You start, you read the number, then you find the mod 2. If the mod 2 is equals to 0, it means it is even. You can see that we indent this statement. Okay. Otherwise, we print odd number. Okay, then we end the if statement, then we end the entire program. So start, end, start, end. If you end it. All right, so there's our pseudocode, very easy. So you can see that this course is somewhat simple to follow. All right, what about this? Can someone tell me what this does? Well, yes, Akinlade. Yes,
All right, sir.
Akinlade.
This is to calculate like simple interest, sir.
Yeah. So one thing you are able to see that from our algorithm, we said understand the input. Okay, we understood the input, what you need to to compute. What do I need to compute the simple interest? I need the principal, I need the rate, I need the time. So because I know PLT, P times R times T divided by 100 equals the interest. Okay, all right. So first of all, I know the input, then I know the process. This is the process. What do I do to the input? What do I do to it? A principal, time. And when I divide it by 100, the result is now saved where? You can see the arrow. It's saved where? Into the interest. Then I can then print the interest. To print the interest is another step. To read a statement, to read the input is another step. To do the computation is another step. So always ask yourself, what are the inputs I require? What are the outputs on the process I need to carry out? And what will be my output? All right. So I want to believe, I want to believe that is all to today's lecture. We've been able to look at Flowchart, the advantages, the disadvantages. I've also been able to look at pseudocode. Now, with this now, I can actually decide to translate it to actual code. Okay. Electrical students, have you been taught any programming before? Anything on programming? Any programming language?
No, sir.
Hello?
No, sir.
No.
No, sir. No, sir.
No,
Wow.
sir. No, sir.
Okay. That's fine. That's a huge disadvantage to you guys. But let me see if I can help out a bit. Let me see if I can help out a bit. This could be a revision for computer engineering students. Okay, so if I have all these statements, I can translate it to actual program. So we have several programming languages. You have Python, C, C++, Java, and all that. Okay, so for my year one, for my computer engineering student, we did C programming. Okay, we did C programming. So let's see what we can do. How can I translate all this pseudocode into an actual program? Let's see. So if you have to write any program, you will need what we call an IDE, integrated development environment, an environment uh, where you can actually write program. Okay, so sorry, I don't. Okay, let me do this. Let me start from the beginning. Let me start from the beginning to show you guys how you can work with this environment. Okay, so let me close workspace. So in this environment, every new program which I want to write is seen as a project. Okay, it's seen as a project. So you click new project, look for your name. Okay. And click console, click go. Depending on which language you want to use, I can decide to use C++, almost the same. Um, let's just say GET211. All right, GET211. Next, I choose my compiler. The compiler is a program that helps me convert my high level. I'm coming, please, a minute. I have someone with me. Okay. Yeah. So convert my code, my high level code. Okay. The instruction I've written back to machine language to become executable. So, um, uh, so the beautiful thing about this ID, it gives me a minimalistic uh, um, header file structure for me to write my code. Okay, so IOStream is more like an header to be able to that takes care of my input and my output. Input keyboard using keyboard, output if I want to print to the screen. So it has a basic. I can here. Let's imagine this is my code. I can come here and just run it to see at least the platform works. Right. So you can see hello world. So I can edit this my statement and say work so get 211 programming class. This so the any string I want to display on my screen, I put it in quote, and I use this keyword to say compiler output what I have to the screen. You take this, look at the flow, you can see this arrow, this output, okay, operator, or like take this and let it flow to my screen. This is more like to the screen, okay, so it takes it and prints it to the screen. Okay, you can say welcome to GET211 programming class. All right, so that's just it. That's just it. So I can write my program in C, C++. Oh, sorry. Let's see. You want to compute the area. It says we should start, we should read length, we should read width, the width, and we should compute. So the first thing we should do is for us to create a variable that will store our length. Okay, we can just do it in this way. We can say int length, um, int length. Let's just say my length is 50, okay, and my weight is 100. Okay. Then it tells me, then compute, multiply, and save it in area. I can come here and say, oh, my area also is an integer. Integer is a data type that allows you to store whole numbers, okay? No decimal point. Okay, so you can come here and say int area, because I know that this length and weight, they are integers. They don't have decimal points. But if they would have decimal point, there's also a data type which we call float. Float is a data type that helps us store numbers with decimal points. Okay, so I can say int area equals length times what? Width. And every statement you make, you end it with a semicolon. It's just like whenever you write a sentence, you stop, you end it with a full stop, right? So then it means I had my length, I have my width, and I assign 50 to it, I assign 100 to it. Then here I'm multiplying it. Then I can say, oh, I want to output the result. So I will use the keyword output, and then say the area is, I can do this and give it a tab spacing. Say, okay, display my area. I can end the line also, end the line, and I'm done with my statement. So if I run it, I'll see the area is 5,000. Okay. If it is 120, the area should be like 6,000. Okay, the area. Or I can say the area is this. Just do this meter. Let's say meter square. That's square. Okay. So on it, and you see 6,000 meters square. Okay, this is not flexible every time I have to change it. But what if I want to tell the user to always input? Okay, always input for me. You can see I've translated that program into code. So variables like length, like width, help us to store values. Okay, so the variables how we use, how we need, okay, will first of all have to be defined in languages like this. Then I can ask the user, okay, first I can ask the user, please input your the value. I can say input the value of length. and you can say and width. Okay, input the value of length and width, come to a new line, and I'm done. Then I can come here and say scene for input. Now look at this. Your output, like your keyboard, you take your in on your string and you take it and it flows like this to your screen. Okay, so from the keyboard, it flows using this direction from my keyboard. It should go where, whatever I type should go to where? To my length. I have to my length, okay, and it can go to my width. So, okay, so after I've gotten my input, that's what it told us. Read length, read width, then you multiply. So with this, anything I type will be saved, first saved to my length. Anything I type then saved to my width. Okay, then it can multiply. So let's run and see what we have. Input the value of your length, let's say 50. I press my enter, input the width, right? Let's just say is 30. What do I have? 1,500 meters square. Wonderful. Okay, so I can write a program to always reiterate. If I want to keep going on and on and on, I can write a program like that. So you can see my high level language, my pseudocode, I can translate it into. So let's see, can we write a program like this? Yes. So read the number, then if the number is this, then print out. Yeah, we can write it. Let's see. So I can come here, I can delete my code. Let's say int a number, that's the number, okay? I can input the number directly or ask the user input a value. Okay, so let's ask the user to input a value. I need to print this to the screen. Input any value. Okay, input any value. Then I say come to a new line. I'm done. Then if I want to input any value, I use my cin to input. And where should it be saved? Whatever I type on my keyboard should be saved in number. Yes, Ayodeji.
Yes,
With
sir.
this,
Sorry. Yeah, I want to ask you,
continue.
sir.
Yeah,
The previous example you did, like the
yeah,
one with length and width, that you wrote 50 and 100. When you
yeah.
used the call out function, I don't know, yeah, call out, you ended it with end line, but yeah, now you are not ending it with end line. Why, sir?
Oh, okay, okay. I can end it with end line. Okay, let me comment this out. Let me comment this out. Look at this. I'm not using any, this cout statement, this cout keyword will help me print this on the line. So look at this. When I run this, you will see that input any value. The next thing you have is process returns, blah, 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 0. Okay. But if I want to put a space between after this input any value, I want this space so that this does not module up. Okay. I hope you understand what I'm trying to say. So I can come here after typing it, I can say end line. Okay, end line will give me a space. Let's run. You can see there's a space. So I can use multiple end line, more like 2 end line. It gives me additional space. Okay. It separates, you can see, so that I can clearly see what I've typed. So sometimes I don't just want to use the end line. There's another format, should I say, escape character called /n. It means new line. /n means new line. Okay. So I can also, if I use that, okay, don't let me use the /n for now. Let's run and see what happens. You can see there's no space. Everything is modeled up together. Okay, so if I say /n now, what do I see? /n also will give me a new line. Okay, so if, let's say, input any value, let me now say, and the program will determine if, sorry, will determine if even, okay? Look at the /n is whenever you output, when you see /n, it means new line. It breaks it to a new line. So what it would do is it would begin to output, input any value, then on a new line, a separate line, it will continue add, and the program will determine. So that's the essence. You can see. Can you see? So I can come here at the tail and /n so that it doesn't model everything up. Okay, you can see. So something like this. Let me just leave it that way. So this keyword is for input. Anything you type to the computer will flow and be saved where? Your number. Okay. So I've been able to save it. Then I can come here and decide I want to test if the number is odd or even. I can then say if I want to test, I use the keyword if that number what I have mod 2, okay, is equal to 0. If it's equal to 0, what does that mean? See out, it is even. It is an even number. Let's just say it's an even number. Okay. Or otherwise, I can just come here, say else. Otherwise, print is an odd number. So, oh, sorry. Shift Home, Control C, come here. Otherwise, print it's an odd number. Okay, so by the time I run it, input any value. So it's expecting me to input any value. So let's say 55. What do you think it will give us? Even or not odd?
Odd.
Odd. You can see it's an odd number. So if I run it, let's say I have 22. 22 divided by 2 is 11, remain that 0. The modulus, yeah, so it's an even number. So I've been able to translate. Ayodeji.
Sorry, sir. I want to ask a question.
Yeah.
Said every statement should be ended with semicolon, but after the if statement, you didn't add
Yeah.
semicolon.
Yeah. The if statement does not need a semicolon. If you terminate with a semicolon, you won't have the right. So the if statement tests whatever it's in the parentheses. Okay, it tests it. If it is true, it prints the next one. But if it is false, then this else statement will be printed. It tests it. So what we're doing is the number, if you find a modulus of it, modulus 2 of it, if the remainder is 0, okay, if the remainder is 0, then it gives us is an even number. Otherwise, it gives us is an odd number. Okay, so it won't work. So look at it. It will not work. So The beautiful thing about all these IDs is whenever you have an error, it will show you where the error line. You can see else without a previous. You can't use an else statement without a previous if. So because you truncate it, it's complaining. By the time you click it, it's telling you the problem is around this area. Okay, so that's just out, right? Let's see another one. Do you have any question? I can see someone muted themselves. So also, I believe you guys can code this. I've done something similar to it. Let's code. Let's write code to calculate the simple interest. So the simple interest now, let me show you something. Let me show you something. If you don't use the right data type, now there's something called data type. Before you create a variable is a location in your computer memory. Okay, it's a location where you can save a value. Okay, so when I created a variable called number in my computer memory, there's a space being reserved for me where I can, that is called number. Okay, where I can save a value. So it's called number where I can save a value. Now the type of value I can save, is determined by this data type. Okay, so I'm saying create a space or reserve a space for me that can save what? Whole number. If it were to be floating point number, that is to say floating point number are numbers that accept zero or decimal points, like 100.57, 3.142. Those are floating point numbers. But integers are for whole numbers, especially when you are dealing with your age. Your age is always integer, okay, and all that. So if I don't use the right data type, it would affect me. So let's say this is 56. Maybe I put it as 56. And I want to display the value. I want to display the value. Okay, what do you think will come out? It will give me what? 56. What happened to the decimal points? It is, truncated. The decimal point is truncated. You can agree, you can assume, oh, it's not no big deal. That is not necessary. It's necessary. If it's not necessary, I can do that with your CGPA. You are in 4.98, or do you understand? And I cut off the 4.98. Your CGPA is 4. The next day, I agree with you. I want to believe you will not sleep well if, let's say, it is you got the information late at night that your CGPA is 4, not 4.98. Okay, that is crucial. So you need to use the right data type. So if I change it to the right data type, like float, at the time I want to print it out, you will see that it prints out the right value for me. Okay, so we have other data types like char character to say help us. So alphabet or alphanumeric. So I can display. You can see I created a variable, and inside my variable, what is in it? A. Okay, and input anything. So I'm displaying what is in that variable. Okay, so see A. Okay, sometimes I can put, let's say 79, a number. So char and display it, it will treat it as a character. There's something called ASCII character. So that's O, let's say 91. One should either be an A. Okay, that's a bracket. That So I can print the ASCII character. Okay, I can print the ASCII character. That's all the ASCII character. That's no problem. Okay, so that's variable for you. So I've talked about char. It allows me to have any special character, just one character alphanumeric. It could be at or something like this. Let's see, we have at, yeah, at. So you put it in just a single quote. There's another one called bool, bool, bool number. Remember that when we are talking about bool, if you guys can remember those I taught in CP, like CP 115, if you have to use bool, you need to include std bool header. Can you still remember? But in C++, all those things were corrected. Okay, so bool, just write true or false. Just say true. Okay, so true is saved as 1, false saved as 0. False is that. Okay, so that's it. Now let's say you have, let's say you have an integer value and maybe you have a number. Now another thing you could do is if you have a floating point or even an integer number, you can express it in a scientific way. Okay, in scientific or standard form, you can write, you want to write 2000, you say 2 times 10 raised to power 2 times 10 raised to power 2. This is 2000. This is 200. Okay, 2000 is 10 raised to power 3. Okay, so here also you could also do it in scientific way. You could actually say is 2 exponential 3. Okay, 2 exponential 3. We end every statement with semicolon. By the time you print it out, you have 2000. Okay, if you have a floating point number, there's also bool, which I forgot to say. You can say 2 exponential minus 3. Okay, you can say 25 exponential minus 3. We have in 0.025 or thereabout. Yeah, 0.025. You can see. Okay, so you can write it in this form. You can multiply scientific times and all that. Okay, so those are variables basically. Those are variables. Then you can make decision. The next thing about after creating variable. Now this equal to is called assignment operator. An assignment. What is on your right hand side is being placed inside what is on your left hand side. Okay. What I've forgot to teach you or to quickly show you is a variable can be modified. Okay, so if now I can come here and say my number is now 50. Okay, so I can change the content of any variable now. Okay, but if I don't want to change the value of a content, I make it a constant. Okay, constant. In scientific terms, we always make use of constant like pi, Avogadro's constant, Planck constant. Do you understand? We always have constant. So if I have my constant as 3.142, I can say this is pi. Okay, I can say this is pi. If I try to change it, I'm going to be having issues. If I try to run it, it will not allow me. You can see pi. So it says assignments of read only. Pi is read only. You can only read it. You cannot write to it. So we always have what we call read and write. Okay, you cannot write to it. You cannot write. When you're writing, it means you are changing what is in that location. But what is in that location, you can read from it. So it is only read only. You cannot write to it. Okay, so that's spy. Or you can do what we call macro. In macro, you can do what we call symbolic representation. You can say hash define pi to be pi, use capital pi to be 3.142. So then I can come here and say pi. Sorry. This means anywhere you see pi, represent it as 3.142. So I can say pi times 5 or 50. And do this. Do pi times 50 and display it to the screen. That's what it means. So that should be okay. So those are ways you can write. But however, I've explained variables, constants. You can then, if you have variables, you can make decisions in your variable. So if I have a variable called n and I say n is 50, okay? N is 50, I can then make a decision. If I want to make a decision, I use the if statement. If n is greater, if n is less, if n is greater or equal to, if n is greater or equal to 50. If n is greater or equal to 50, display to the screen. It's greater. Okay, so that. Let me mute this lesson. I don't like stuff on. So you can do something like this. If n is greater or equal to, just say it's greater. Okay, greater. Okay. So these are decisions. Make decisions. So what is here must be true. Must be true. Okay. Must be true before it can. It's true. Okay. If it is not true, that is to say, if it is false, it will not run. This will not run. This will not run. Okay. If it is false, it will be blank. Not see anything on the screen. Good. You can see. So it must be true. So if n is 50, if we want to compare n to be 50, we'll say if n is equal to 50. So how we do equal to is double equal 50. So if n is equal to 50. Why? We cannot do this because that equal, this single equal means assignment operator. This is comparison operator because we are comparing. Okay, so we can say it's equal. So if it is true, it will print. If it is not true, it will not print. If you would have multiple statements, like this, okay, and you want them to be printed at the same time, it's always good to put them in a block. Okay, to put them in a curly brace is a block. So put them is equal. It's 50. Just 50. Okay, put them in a curly brace at its front. Okay, so if you want to have an alternative, you use else. Otherwise, else means more like otherwise. Otherwise, you can say it's not equal. Okay, so n is 50. So let's say n is now, if n is now 70. Is 70 equals to 50? No. So which one will print? Which one do you think will print? It's not equal. Okay, so let's run. It's not equal. Can you see? Because this statement does not evaluate to be true, then this other one will be printed. Sometimes you could have multiple statements which you want to compare. You can say if n is greater than 50 and n is less than 100. If it is greater than 50 and it's less than 100, you can say it's between 50 and 100. Okay, it's not between 50 and 100. Okay, so 70, it will print it's between 50 and 100. Okay, if it is, let's say 20, is 20 greater or equals to 50? No. So this AND statement will evaluate the two. The two must be true for you to have a true here. Okay, just like in Boolean algebra, you need to have true to have an output that is true. So this is an AND statement. Okay, so is 20 greater or equals to 50? Is not greater and is not equal. So this is not true. But is 20 less than 100? Yes, this is true. But it will not give us a true. It will not print this because both of them are not true. Okay, so it will print is not between 50. So those are decisions you can make. All right, so you can go to the next concept which you need to know is if the next concept is iteration. If you want to keep running a particular command every now and then, the class has reduced. Okay, so I can if I want to continue to execute something over and over, then I will do what we call iteration. So for me to do an iteration, there are about 3 statements for you to do an iteration. There's a first statement. Okay, there's a first statement. Shuku, sum to shuku.
Yes,
Yes.
sir. I forgot to ask you before, but when the whole of our code is wrapped in a function called main, is it always meant to be like
Yeah.
that? Is it like convention?
Yeah, that's the convention. It must be wrapped in a function called main, at least for beginners like you. You understand? Now,
Yes, sir.
we can have other functions. Right? But where the compiler starts execution from is from the main function. That's why it's called the main. This is a function. It's called the main. You can have your other function, but where it starts from is called the main function. Yeah, so that's just it. Okay, so if I want to do iteration, I use and I know the number of times I want to do my iteration. I can use a for loop. A for loop works in this way. You have your starting criterion. If you don't have a starting criterion, you use your semicolon. It means I don't have a starting criterion. Okay, so you have a stopping criterion. Okay, let's say I can say n is 100. That's when I want to stop. Okay, so I can just say when n is equal to 100. Let's say plus minus minus. No, let's just say equals to 0. Equals to 0 minus 1. Okay, I can just say I want to confuse some of you guys. I love the plus. Okay, plus. That's it. This bad program. Let me make it easier for you guys, or even make it more easier. Okay, so iteration starting criterion, not starting or stopping criterion when f is equals to let's just say greater or equals to 0. Let's see. So it stores the body. You can see it prints I love C++ 100 times. If you count it. Okay, so that's just it. So when you want to do something over and over again and you know the steps, if you want something to print forever, then you have to remove the starting, stopping, and now you implement it. Okay. If you do this, it will print over and over again until I press you escape. So if you do this, we run to infinity. It's still running. You will see it blinking. It's still running to infinity. So stop that. So that's just it. You can print, let's say n equals 10, 100, starting, stopping. Let's just say n greater or equals to 0. The same thing, minus n. I can just say n. I can display n. N equals okay. N equals n. Say n9. N equals n9. So on this, and it will print from where? From 100 down. 100 down to what? Down to 0. So starting, I did not specify where it should start. All I just say print for me n. It will come here to check is n greater than 0, greater or equals to 0 if positive. So it does all these things. So all these things, I will stop here. There are so many things I can't teach you programming within an hour. Okay, so you can translate your code. You can translate your pseudocode, your flowchart into actual code. And in actual code, you need to follow syntax. If you don't follow the syntax, you would have issues. Okay? Yes, come in. You will have issues. So I'm going to stop this way. I'm going to stop my class this way. Here. Do you have any questions? Victoria. Yes.
Good morning, sir.
Yeah, good morning to
So,
you.
sir, please, it's about the project that you gave us, the assignment.
Which assignment?
You gave us the project, this GET211.
And what is the project? I just asked you a question now.
Excuse me, sir.
Victoria,
Sir?
what's the project?
Sir, I've forgotten.
Can you imagine? You don't know what you want to say. You can sit down. Sit down. It's not around.
Okay, sir.
Yeah, opposite. Okay, so who want to help out? Ayodeji.
I want to tell her that you are not the one that gave us the assignment. Like the
That
project.
should be Dr. That is Dr. Adewade, right?
Yes, sir.
Okay.
Lecturer that took us before you.
Yeah, that's Dr. Adewale. Is that fine? Are we good? Are we good?
Yes, sir.
Okay. Any question before we call it a day? Any question? I hope we understood. You understood all I've been teaching all this well, even up to this present moment.
Yes, sir.
All right. Take care, guys. And have a fun-filled day. So after the class, when I finish my section, I can share my slide with you.
Okay, sir. Thank you, sir.
Thank you
All
very
right,
much,
take
sir.
care. Yeah, I can also make the video available online. I'll let you know when I'm ready. Take care, bye.